So solution to that last problem, we have to do it by graphing, but when you graph this, the solution for k ends up being 0.557. So if we take a look at the graph here, at about 0.557, right about there, we're going to get our maximum area triangle, okay, in that space. Okay, so let's look at this next equation here, this next problem. So we have the position of the particles given by this curve, okay, 1/3 ln x, and we want to know when the coordinates of the pointers closest to the origin. Okay, so what is the closest point to the origin? Well, basically that's going to be the point where the tangent, the perpendicular to tangent line, is going to get us to that point. Okay, so that the closest point is always going to be 90 degrees from that line. So how do we find this point? Okay, so we need to come up with a system here. Now we could come up with we could basically come up with this distance formula and minimize the distance. However, if we use the property that this tangent line and this line here, this line must be perpendicular to that tangent line, we can do this. We can generalize this coordinate as x, y, and basically the slope of that red line is going to be y over x. Okay, so the slope of the line so I'll call it the connecting line, is equal to negative y over x. Okay, actually it's not negative y over x, it's just going to be y over x because y is a negative position, so it will be negative inherently in itself. Okay, now we can then use the property that the slope of this line is going to be the negative reciprocal. Okay, so the tangent line so the slope of the tangent line is going to be the derivative y prime at x. Okay, so let's find out the derivative and calculate and see what the expression for that tangent line is. So y prime is equal to 1 over 3 x. Okay, so that's the slope of my tangent line. Okay, the generalized equation for the slope of the tangent line. And what do I know about these two equations? Okay, I know that these two equations are negative reciprocals of each other. So I know that the slope of the perpendicular line of this is going to be negative x over y. And I know that these two slopes must be equal to each other. So I know that the tangent line slope, 1 over 3x, and I'm going to maybe color this. Okay, so I know that the slope of the tangent line, okay, this one here, 1 over 3x, 1 over 3x, is going to be equal to the perpendicular slope of that line. Okay, so the slope connecting line is going to be this line here, and I'll just draw it in my picture just so that we can kind of see. So the green line is going to be this one, is going to be that, and then the purple line will be our tangent line. Okay, so we know that there now, since I've done the negative reciprocal here, maybe I'll just fix that. Okay, so the negative reciprocal is equal to that tangent line. Okay, so I still can't solve this for x because I have a y in there, but I do know that my y is defined up here. Okay, there's my y. So I can replace that with an x value. Okay, so I'm going to replace that with 1 over 3x is equal to negative x over log x 1/3 log x. Okay, now I can solve this equation. Okay, so I'm just going to make this equal to, this is going to be, let's see here, log x comes to that side. I'm going to make that divide 3 times 3 onto that side. So negative 9x squared. And there's my equation, log x plus 9x squared equal to 0. Again, this is an equation I cannot solve algebraically, but once I have the equation, I can just graph the solution and find the solution by graphing this. So I'm going to do log x plus 9x squared. And we want to know where that graph crosses the x-axis. It's probably going to be somewhere near 0 there. Yeah. Okay, so the solution is going to end up being at x equals 0.34, 0.34, and we had to figure out that by actually graphing that solution. Okay, and so in this case here, we solved this. The second question here is, what is the rate of change of the distance to the origin with respect to x at the minimum distance point? Well, if the rate of change, if it's getting closer and closer and closer as we move in this case from here to here, then it's going to move farther and farther away. So it's going to be negative distance, d by dt. So on this side, I'm just going to draw it out. Okay, on this side, dd by dx is negative. Okay, on this side. On this side, dd by dx is positive. So what that means is right at that point, okay, as it goes from reducing its distance to increasing its distance, well, it has to be 0. So the rate of change is distance with respect to x. So in this case, the change in the distance with respect to x must be equal to 0 at that minimum distance point.